All right, so we're going to talk about the general form of conic sections, and I'll just jump right into it. Okay, so the general form of a conic looks like this. Ax squared plus cy squared plus dy plus ey plus f equals 0, where a, c, d, e, and f are all real numbers. And I know what you're thinking. Where did the b go? This is how I've seen the conic, like the general form of the conics. I don't know why b gets skipped over, but yeah, there's no b in this equation technically. Doesn't really matter because we never we never really write it in terms of like just letters. But so yeah, all these a, c, d, e, f, these are real numbers, and then a or c, one of them has to be non-zero. So you can't have both this and this have a 0 as the coefficient. So this is what makes the general form of a conic. And okay, so like how do you know from that equation which is which? So this is like the technical list. Like for a parabola, a or c must be 0, but not both. For a circle, a will equal c and neither will equal 0. For an ellipse, a does not equal c and a times c will be 0. And then for a hyperbola, you have a times c will be less than 0. This looks scary, like it's a lot of stuff you have to memorize. I think that actually when you start breaking it down, this is a lot more intuitive than you'd think. So, just note these things, but we'll make this more intuitive versus something you have to memorize. So what I want to do is I want to identify the type of conic and then graph it. And I'll show you the technique you use then to graph it, which if you've been watching some of my example videos, this probably isn't too much of a surprise. Okay, so looking at this equation here. So I've got x squared minus 6x plus y. So notice I only have one squared variable. This tells me right away, slam dunk, this is a parabola. So when you only have one squared term, either only an x squared or only a y squared, it's a parabola. Okay, so the next thing that you want to do is just think about like what's the best way to graph a parabola. And I think actually with parabolas, it depends like on the context because there's two forms of the parabola. So these are technically the two different forms, and we've talked about this in some of the other videos. So I would say you could graph whichever way you want to. It's actually pretty easy to convert from this form to this form. It's just kind of I'll show you how to do that in a second. But if we're talking about like needing to put the parabola in the conic section form, just FYI, you are going to have to put it in this form. So there's reasons that you might personally want to switch between the forms, but if we're in a conic section context, then you're probably going to want to use this form. Okay, so what I'm going to do then is I just need to figure out like, all right, how do I make that work? So with a parabola equation, the big thing I think about is that I need the x's on one side and the y's on the other. So I can start with that. And then with the x side, I want to write this, this is x squared, sorry. The x side, I want to write this as a squared binomial. So I need to complete the square on this side. So if I'm completing the square here, I have my b is equal to -6, my half b is equal to -3, and my half b squared is equal to 9. Okay, so then what I'm going to do is I'm going to add that 9 to both sides of the equation to keep it balanced. And then I can rewrite this as, as x minus 3 squared equals -y plus 9. Now, notice this side, we want a positive y. So now I just have to force that. So I'll clear a little space. And so just to make this look like the right format, I'm just going to factor out -1, and now this becomes y minus 9. And now I have this in the form of the conic section. So I can technically graph now with this format, and I can answer all sorts of questions about this. So usually when you're talking about conic sections, like you want to construct using the idea of conic sections. Now, if you're like, no, I really want to draw it like a normal parabola, like the way that I've originally learned it, you can do that, and you can transform this equation. all you have to do, right, is just divide out by what's ever in front of the parentheses. So in this case, this would just be -1 x minus 3. God, why can't I not write it squared? Okay, and then this would be y minus 9. So you could write it like this, tomato, tomato. But if you're trying to get used to the language of conic sections, this would be my preference for you. So now let's think about just like, how can I sketch this? And you can sketch this, I think, somewhat easily. So, okay, the vertex in this case, so let's see, my vertex, what is my vertex? My vertex is going to be 3, 9. So 3, 9, let's say that's like, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5. Okay, so here's my 3, 9. And then, so what's my p in this equation? So again, I'm trying to graph this using the idea of conic sections. So this part here, let's see, maybe I'll use a different color. This part here, this is my 4p. So my 4p will equal -1, which means that my p equals -1/4. So this parabola opens downwards this way. And so the focus is going to go this way. So I would count down 1/4 in this direction, and then I would technically have a directrix 1/4 in this direction. And my graph's a little close in this case, but now I can draw a parabola, at least that is kind of thinking about conic sections. So that would be how, that's just like a rough sketch to kind of get the idea. Okay, so let's try another one. So now I've got 2x squared minus 8x plus 2y squared plus 20y equals 12. Okay, so just by looking at this, I can tell what type of conic section this is. So we have two squared terms, and then notice the sign in front of the squared terms. This is positive, this is positive. So that is a slam dunk that this is going to be an ellipse, because ellipses always have two positive square terms. So now we can complete the square on this, which we've done in some other videos. So if you remember that, you might want to pause here and give that a go. Okay, so I'm going to just jump right into it. So we can't complete the square unless we factor out the 2's first. So I'm going to factor out the 2. Okay, and now I can complete the square here. So here my b is going to be -4, my half b will be -2, and my half b squared is 4. And then here I can complete the square. So here my b is 10, my half b is 5, and my half b squared is 25. So now I can add those constants in. So this is going to be +4. And then I broke this down in my example video, but I'll remind you of it again. So the thing about this is when I add the constants to the other side, I have to respect the fact that there are these 2's in front. So I'm going to take that 4, but I need to multiply it by the 2. So I have to bounce it off what's in front here. Same thing for the 25. So this is going to be plus 25 times 2. And now I'm in business and I can keep going. So this is going to be 2 times, so now I can factor this as x minus 2 squared, and then 2 times y plus 5 squared. And the other side will equal 70. Okay, so let's clear some space. Okay, so as we know, we want the equation to always equal 1. So to make that happen, we're going to divide everything by 70. And now what we find is that we have x minus 2 squared over 35 plus y plus 5 squared over 35 equals 1. And so from this equation, actually, this is not an ellipse. This is actually a circle. How can I tell? It's because these two numbers are the same. So when these two numbers are the same, you know that you have a circle. And so this is a circle with radius square root of 35. And let's see, if I punch in square root of 35, so that's going to be pretty close to 6. We'll say 5.9 just for reference. So if I just want to draw a little sketch of this. So there's my center, and then I can go out, let's see, 1, 2, 3, let's see, somewhere around here, here, 1, 2, 3. Let's pretend we're out around here. So you're gonna have a circle going like this. Pretend that looks more circular. I'm running out of space here, but hopefully you kind of see the idea. So this is gonna be a radius of r equals square root of 35. Now with the circle, you have a radius. With an ellipse, you can't have a radius because a radius has to be the same distance all the way around. Like I said, this picture is clearly not to scale, but hopefully you had a little more space so you could draw something a little more circular. Okay, so for this next one, so maybe you want to just read it over for a second. I'll read it to you. Y squared plus 6y minus 4x squared plus 8x equals negative 6. So right away, I can tell what type of conic section this is. This is going to be a hyperbola. How can I tell? It's because this is positive and this is negative. So when you have one positive square term and a negative square term, it's automatically a hyperbola. Now, to put this into a form where we can easily graph it, this is kind of tricky. I talked about this at length in one of my example videos for hyperbolas and completing the square. So if you want to see more examples of that, you can check that out. Okay, so the key to this is actually to factor out the negative before you do anything else, because this negative is going to severely impact your choice of B. So even if this were a -1, I showed this in a few examples in my example video, when this is a -1, you still want to factor this out because otherwise it just screws up your choice of B. Okay, so anyways, so now, let's see, here my B is going to be 6, so my half B will be 3, and my half B squared is 9. Here, my B is -2, so my half B is -1, and my half B squared is 1. So I'm going to have y squared plus 6y plus 9 minus 4x squared minus 2x plus 1. All of this equals -6 plus 9. Oops, let me color code that. So plus the 9 from the other side minus, oops, colors are not working with me here. Minus 4 times 1. So again, that 1 has to get bounced off the number in front here, and this happens to have a minus sign in front of it, so that's what we carry to the other side. So then I can write this as y plus 3 squared minus 4 times x minus 1 squared equals, this equals -1. Now, before you're quick to say, oh wait, this equals a negative, so this can't be a conic section. So we're actually not done. So, okay, let's clear a little space. And now let's keep going with the dun 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 plot twist. Okay, so I'm gonna divide everything by -1 because I need this to be a 1 here, right? So if I divide everything by -1, so check out what happens. Think about the signs. This becomes negative y plus 3 squared over 1. This becomes positive 4 over x minus 1 squared over 1. And then this whole thing equals 1. So this is a hyperbola. We have to mess with the equation a little to see it though. So notice now, by dividing by -1, the y became the negative. So I can rewrite this as 4 x minus 1 squared, minus y plus 3 squared equals 1. And I can put these over 1. Now, the last thing you're probably wondering about is like, what is the deal with this 4 here? Because like normally we have the number on the bottom. So you might remember a couple of times where we ended up with a fraction in the denominator and then we flipped it so that like we wouldn't have the fraction in the denominator. We're kind of going to take that now and reverse that. So let me clear space one more time. And let's just go through that thought experiment for a moment. So this is going to be x minus 1 over 1/4. So these two things are equivalent, right? Because if I wanted to rewrite this without the fraction, it would look like this. And I put this all over 1 just for a visual marker. We technically don't need the 1s, but I need to graph this. Oops, and I forgot all my squares. Okay, so this format now will allow me to easily graph the hyperbola. So let's go ahead and do that. Okay, so we're going to have a center of 1, -3. So let's see. 1, -3 is here. Then in the x direction, I count out 1/4. And in the y direction, I count out 1. So I have something, here's my little box. Here's my asymptotes. And so this is opening in the x direction now. So it looks like this. So this was actually kind of a tricky problem because it just had, we knew it was a hyperbola, it just ended up opening in the different direction than we thought. And then for this last one, so I thought I would just throw in one just to remind you guys of this last concept and force us to graph it. So I think we kind of understand the whole completing the square thing. So if I have an equation in this form, so this is not in any standard form, so always your best practice is to divide everything by whatever you need to do so that you can have a 1 right here. So then this will become x over 9 plus y squared over 1 equals 1. And so this is an ellipse with a 0, 0 center. So I can count 3 in each direction on the x-axis, 1 in each direction on the y-axis, and I can get this ellipse here. So just wanted to take a brief moment to remind you of the construction of those. And okay, so that's it. So that's how you deal with the general form of a conic section. You really just got to complete the square and kind of have a guess as to what type of shape it is before you go into it. And I will catch you guys in another video.